Hi, today we're going to look at interpreting linear graphs. So linear graphs are graphs with straight lines. When we look at graphs, the y and x axis, we have to make sure that they're nicely labeled. Today we're going to look at distance and time, for example, and with distance we might have either meters or kilometers. Those are the ones we're going to look at today. And for time, we can have seconds, minutes, hours, whatever it is, you have to make sure that you label your axis accordingly. Then we're going to look at water height versus time. So for example, if you're filling up a jar or your cup, the water level height is going to slowly increase. But if you have a bucket with a little hole at the bottom and it's leaking, then the height of the water is slowly going down. Here we have a graph of distance from home over time. Now it doesn't matter what that number is, I just want you to see that if the line is horizontally straight and parallel to the x-axis, then what does that mean? At the start of the event, you're that amount away from home. After some time, you're still that amount away from home. So you have stayed in the same position. So a line that has that gradient or horizontal like that means you're not moving, you're stationary. What about a graph that has that line? Let's have a look. Let's read this. At the start, you are 0 away from home, so you're starting from home. And then after some time, you're a little bit, so that distance away from home. And as time progresses, you are that amount from home. A bit longer, you are that amount from home. So you're going further and further and further away. So a line like that, it's saying that you're moving away at a constant speed. What about this blue line here? Let's compare them. So this one is also moving away from home, but the blue line is showing that that person, let's say after some time, let's say at this time here, the pink has only moved this amount of space, this distance, whereas at this time, the blue has moved that amount of distance. So after some time, the blue has moved more distance. In other words, the blue is moving faster. What about a line that's flatter or lower? After the same amount of distance, we can see that it's only moved this amount, and at the same time, the pink line has moved more. So the green line has moved the least. So it's moving the slowest. So fastest, slowest. Fastest has a gradient that's almost standing up, and slowest has a gradient almost lying down. So faster is when it's close to the y-axis, slower is when it's close to lying down. A silly way to remember this is you're not moving when you're lying down, you're only walking or moving when you're standing up. Fastest, slowest, slowest, fastest. Remember it. And recall that the gradient is a distance over time. So how much far you've gone over that period of time. That's why the speedometers is kilometers per hour, for example. What about a line that looks like that? So at the start of time, you're that far away from home, but as time progresses, you're only that far and you are that far away from home, and eventually you are home. So you're far away, and as time passes, you are at home. So you're walking towards or coming home. So this line going down doesn't mean it's slower than the line going up. It just means it's going towards home. What about a line, this blue line here? So it starts exactly the same distance as the pink one, but it gets home much faster than the pink one. It only traveled for this amount of time and it got home. So the blue one is faster than the pink. So what would something slower look like? So this is faster than the pink. Something slower means it has to take more time. So if we start at the same position, it would look like that. So that one took a lot longer to get home. So that one is slower. So let's check our gradients or the way they look. So here we have the fastest. So see, it's almost standing up. And then the slowest. So the trick is use your pencil. If it's really close to standing up, then it's fast. If it's really close to lying down, then it's slow. And if it has a going down gradient or a negative gradient, then it's going towards its starting position. And whereas if the line is going up, it's going away from the starting position if we're looking at distance times graph. If we change it to water and time, so the amount of water we started off is that amount, and after some time the amount of water is nothing, then again the fastest gradient means it's taking less time to leak all the water, and the shallow gradient is saying that it takes a longer time for all the water to go away. So fastest is always the one that's closest to standing up, slowest is always the one closest to lying down. And then if it's negative gradient, it means we start far or with more water, and then we get to nothing or home. Let's have a look at this distance and time graph. Have a think about this. Are you starting at home, going away, coming back? Or are you away, coming home, and then going away again? So let's read this. You're starting at, distance away from home is nothing. So you're starting at home. After some time, you are all the way that amount far away from home. Then you're not moving, and then you're walking back home. Now, which one is faster? The one that's closest to standing up. So this is away from home fast. This is going towards home and slow. It's like you're running away from home, and then, sorry, you're taking a jog away from home. Then you take a pause, and then you're tired and you go home slower. So fast away, slow going back. Now this is a positive gradient, this is a negative gradient. Remember, positive and negative has nothing to do with fast and slow. It's how straight upwards it is that makes it fast. So fast positive, fast negative. And it's how flat it is that makes it slow. And it's how flat it is that makes it slow. Slow positive, slow negative. Let's have a look at these two containers of water. If I had to pour water from the same tap into these one, which one would fill faster? You might think about, when you're filling your water bottle, you have to be very careful, because once you get to the top, it just goes out really quickly because it's narrower. So the height moves a lot faster for the narrow one, and the height will move really slow for the wider container. So which of these two graphs represent the containers? The blue one is fast, so it's representing the narrow container, whereas the pink one is slower, so it's representing the wider container. What about if I had a container that looked like that? Let's think about this. So the narrower it is, the faster it is, and the wider it is, the slower it is. So it's slow at the bottom, and then it's getting faster and faster. Now this is no longer a linear example, but I thought I'd throw it in there just for fun. So it's going from, use a pencil trick, slow, and then see, standing up. So it's faster. Another example that's not linear that I'll throw in here just to have a look, which glass belongs to which graph? So we can see that this is going from pretty fast to fill in to really slow because it's wider, this is doing the same thing, but not as quickly as that. So the blue one is going slower, see it's getting flat. So is the pink one, but the pink one is going slower, faster. So the pink one belongs to the pink one. So that's just a fun question to throw in. You'll see questions that look more like this. So here we have an example of a graph with filling up water for a bathtub. So the height of the water going up and down. What would this story be like? Now this is not 100% accurate, we're just using the gradients to describe the story. Now we're going to use a pencil trick to figure this out. So it's going pretty slow and then faster and faster and faster. So the water is going high, and then it stops, then it's fast again, it stops, then it's pretty fast, but the water height is going down, and then it's pretty slow coming out that way. So what could the story be? It could be someone has turned the water tap on and left it on for a period of time, and then turned the tap off, went for a walk, got undressed, and then jumped in the water, so that's why it's so fast. And then the water went up because the person's inside there, and then he might be chilling in there, and then he gets out of the bathtub, and then he dries himself a little bit and then pulls the plug out, so then the water drips out. So we can see that these are positive, these are negative, and blue is fast and pink is slow. Have a look at this graph and think about it a little bit. So turning the tap on, paused, water's not moving, jumping in the water, sitting in there, jumping out, and coming out. So that is how much the water went up when the person went in the bathtub. What about this graph describing the distance away from home? So we can see that it is, using our pen, pretty fast. Same. And then pretty fast. And then, oh, this is faster than this one. See, it's more straight up than this one. And then slow. So we could make a story around this. You try make a story, pause and unpause, see if your story matches mine. So here we have somebody going for a jog pretty fast. And then they stop in this section here. Maybe they saw a friend or they had to tie the shoelace. And then they go back jogging. Now they stop to take a break. And then they're coming home now. They're going pretty fast home. Maybe they stop to look at their watch and realize, oh no, I'm late. So they stop for a second and then now they sprint back home. So that's faster. And then maybe they trip. That's why there's a little pause then. And they hurt themselves or they get really tired and then walk home slow. So looking at the graph, we can tell stories. Let's see if you can write a story for this graph. That's it for me today. I hope you understand that positive, negative, fast, whether it's this way or that way, and slow, whether it's positive or negative. So remember those 4 things, and I'll see you in the next video.